So significant figures tell us how many digits are known with certain plus one more that's estimated. These are the rules that we're going to use to help us determine how many numbers to write down from our calculator. First, we need to talk about what numbers are significant within a measurement. First, all non-zero digits are significant. Zeros are only significant if they're between two non-zero digits, like 1, 0, 1. The 0 would be significant because it's between two ones. If it was 1, 0, 0, 1, both zeros would be significant because they're both between two non-zero digits. So it doesn't matter how many zeros are in between. As long as they're in between two non-zero digits, they count. Zeros also count if they're at the end of the number and you physically see a decimal. So if we look at our first example, 2 is non-zero, 8 is non-zero, and 6 is non-zero. So there are 3 significant figures, or 3 sig figs. In number 2, 3, 4, and 4 are significant because they're non-zero. This 0 is also going to be significant because it comes after the 3 and there's a decimal. So this number has 4 significant figures. In our third example, 9 and 1 are both significant. This 0, however, is not significant. Even though it comes after the 9, there's no decimal in the number, so it's not significant. So 910 has 2 sig figs. In our last example, the 6 and the 7 are significant because they're not 0. The zeros in front of the 6 are not going to be significant because they're in front of the 6. So you have to get to something that's not 0 before you can start counting zeros. These 2 zeros come after the 6, so they could count as long as we see a decimal. The decimal is up here at the beginning of the number this time, so they're still significant because they're after the 6 and we physically see that decimal. So this number has 4 significant figures. Now when you do math, you follow these rules about significant figures. When you add or subtract, we're going to use the fewest decimals. In number 1, 5.44 has 2 decimals, and 2.6103 has 4 decimals. So we're going to go with the fewest, 4. So our fewest is 2 decimal places, so we're going to go with 2. So our answer would be 2.83. This is changed to a 3 because it was 29 and the 9 rounds it up. In number 2, 2.099 has 3 decimals. 0.05681 has 5 decimals. So we're going to use 3 decimals. 2.156. When you multiply and divide, you look at the number of significant figures in the entire number. So 2.4 is 2 sig figs, 15.82 is 4 significant figures, so my answer only needs 2 significant figures. It doesn't matter if it's a decimal or not. So the answer here would be 38. 17.982 is 5 significant figures. 4.13 is 3 significant figures, so my answer needs to have 3. So 4.35 would be my answer for this problem. Some basic vocabulary for chemistry is atom, element, and compound. An atom is the smallest unit of an element that maintains the properties. We can break the atom down, but then it will no longer contain those properties. An element is when you have all one type of atom, and a compound is when you have different atoms. You know you have an element because it's on the periodic table. If it's not on the periodic table, then it is not it's not an element. Gold, for example, is on the periodic table, so it's an element. Its symbol is AU. Baking soda is not on the periodic table, so it's a compound. On the test, I will also put down the formula. So baking soda is NaHCO3. So I know that this is a compound because it contains more than one capital letter, therefore it contains more than one element. Sucrose is a compound. Again, I would have the formula written for you. Chlorine is an element. Its symbol is Cl. Water is a compound. Its formula is H2O. So water is 2 hydrogens and an oxygen. Lead is an element. Its symbol is Pb. So sometimes the symbols make sense, sometimes they don't. So you really need to look for that word on the periodic table. Salt is a general term for an ionic compound. Table salt is NaCl, but it's only one type of salt. We can also talk about matter in terms of physical and chemical. Physical properties and changes describe the substance, but do not change the substance. So to say that my shirt is red is a physical property of my shirt. Cutting my shirt would be a physical change. I'm not changing the fact that it's a shirt, I'm just cutting it into 2 pieces. Phase changes are also physical changes. So if you were to go from a solid to a liquid, we would call that melting, and that is a physical change. Going from a liquid to a solid is freezing, and that is a physical change. When you take water and freeze it into ice cubes, it's still water, it's just in a different phase. The only other phase change that I would expect you to know right now would be liquid to gas, and that's evaporation or boiling. There are 3 other phase changes, but I would not expect you to know them at this time. A chemical property, you're actually going to change the substance. When you have a chemical change, that's when you actually do the changing. Chemical reactions always start off as reactants and end as products. So at the rear of the arrow is your reactants on the left, and the arrow points to the products on the right. They're 2 different things. So a chemical change or a chemical property, you have 2 different things. There are 4 indicators of a chemical change. Color change, so going from red to blue or red to white, you're actually changing the color. Forming a precipitate, which is a fancy word for new solid. Forming a gas, which you typically see as bubbles, or absorbing and releasing energy. Absorbing energy is called endothermic, and the release of energy is called exothermic. The classification of matter. So you can have a pure substance, which is an element or a compound, and we've already talked about how to tell the difference. Or you could have a mixture, which is 2 or more kinds of matter, but they have their own identity. In a homogeneous mixture, you have 2 or more kinds of matter, but it looks the same to our eyes. Homogeneous mixtures are often called solutions. So when you make your iced tea, that is a homogeneous mixture because you can't see the difference between the tea and the water. A heterogeneous mixture, you can see the difference. So a heterogeneous mixture is like a tossed salad. You can see the lettuce, the tomatoes, the cheese, the cucumbers. So a heterogeneous mixture, you can see the difference. Homogeneous mixture, you can't see it with your eyes. A pure substance, again, is an element or a compound. CMPD is compound. An element cannot be decomposed because remember, an element is one type of atom and we locate it on the periodic table. A compound can be decomposed chemically, which means we can chemically separate those atoms and create something new. So oxygen is an element because it's on the periodic table. Its symbol is O. Alcohol is actually a compound. It's formed from oxygen, carbon, and hydrogen. Gasoline is a homogeneous mixture. Soil would be heterogeneous because we would be able to see the rocks and the sticks within the dirt. Helium is an element. Symbol is He. Milk would be a homogeneous mixture. Rocky Road ice cream would be heterogeneous because you would be able to see the ice cream, the chocolate chips, the marshmallows. CO2, or carbon dioxide, would be a compound because it's made of carbon and oxygen. Lastly, the periodic table is divided up into several different groups. Periods and rows are what we call the horizontal areas on the periodic table. There are 7 rows and then 2 that are removed at the very bottom of the periodic table, but we don't number those. Families and groups are your vertical columns. There are 18 groups or 18 families. Metals are good conductors. They are malleable, which means that you can shape metals. Luster, which means metals are shiny. And ductile, which means you can pull it thinner or pull it into a wire. Nonmetals are not good conductors, and they are therefore insulators. Metalloids are semiconductors, which means they kind of conduct but are not very good at it. On the periodic table, there is a stair-step line. That stair-step separates our metals, nonmetals, and metalloids. Metals are to the left of the stairs and take up the majority of the periodic table. Nonmetals are to the right of the stairs, and metalloids are along the stairs. The only element that touches the stairs that is not a metalloid is aluminum. Aluminum is just a metal.